Hi, this is Mrs. Ziegler, and I'm going to go over the answers for this graphing practice. Okay, so looking at the graphing practice, what you're doing for this one is you're going to read what the story is and then draw it as a graph. So we see here that a mouse peeks out at 30 centimeters away from its nest. Okay, so from the starting point, which would be here, okay, peeks out and goes at a constant speed for 2 seconds. Okay, so for 2 seconds, so that means 1, 2 right here. And we know that at position 2 seconds, it's going to be at 30 centimeters away. Then it says that for 1 second, they stop. There's no motion. Then slowly moves at a constant speed back to the nest, and it takes 6 seconds to get there. So we know from the nest into the 2 seconds, again, constant speed, straight line. We know there's no motion for 1 second. Okay, then over 6 seconds, so here's 1, 2, 3, 4, 5, 6. So here they return back to the nest. So again, at a constant speed. Okay, so this is what your graph should look like from the story that was given. Okay, so now we're going to look at the next part of our problems. So here we have position time of a graph over time. Okay, it says here, write at least 4 sentences explaining what's happening. Okay, so 4 sentences. Well, here we have for 2 seconds, the truck is not moving. So no motion for 2 seconds. Okay, here's our next one. It's a straight line. Over 2 seconds, they move 1, 2. So for 2 seconds, truck moves 2 meters at constant speed. Okay, so here we have another motion. Okay, again, straight line. Over 1 second, it's negative slope, right? So next sentence we say, for 1 second, for 1 second, truck moves backwards at a fast rate, or at fast constant speed. Okay, and then here over 1 second, 1 second, 1 second, there is no motion, or you could say the truck stopped. And then here moves forward 1, 2. Oops, sorry. Raise this up so you can read. And then here says truck moves 2 meters over 1 second. You could even say moves forward 1 second. Okay. All right, so now this one, we are reading this graph in order to answer these questions. Okay, so first question says, the tram, what is the tram's position at 4 seconds? So here, 4 seconds right here. Okay, the position is 1 meter. Okay, at 6 seconds, so here, 6 seconds is at 3 meters. Okay, now it says, what is the speed from 0 to 3 seconds? Well, over the amount of 3 seconds, we've moved 1, 2, 3 meters. So 3 meters in 3 seconds. So 3 meters in 3 seconds. Oh, I'm sorry, this is seconds. Okay, so that it would be 1 meter per second is what the speed is. from 3 to 5 seconds, again, flat line, so therefore 0, so we're actually no motion. Okay, so the speed is at rest, so there's 0. So it's really no motion, which is 0 meters per second. So then what is the tram? So we asked here, what is the tram doing? Again, no motion. No motion, stop. Okay, now it says here, what direction is the tram going at between 7 and 9? So again, this one means forward, this one means backward. So therefore, this is moving backwards. At what time is the tram at position 3? So position 3, 6 seconds. Okay, 6 seconds. And then what is the total displacement? Okay, so remember, displacement has to do with how far from the starting point. Well, if the starting point is here, and then the end point is here, okay, so it's negative 2 from 3. Okay, so again, starting position is negative 2 minus 3, and then it is how far from the starting point. Okay, so therefore it is, so that's negative 2 from 3 again, so that is negative 5. Negative 5 meters is how far it is from the starting point. Okay, and then what is the distance, or what distance did they travel? So again, distance is, looking at this graph, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. So looking at the graph, the distance is 9 meters. Okay, if you have any questions, make sure you reach out.